में सबसे पहला फॉर्मूला हम देखते हैं. सपोज दैट वी हैव एन एरिया ए से, इसका एरिया वेक्टर हम लेते हैं ए बार. लेट मैग्नेटिक फील्ड की डायरेक्शन जो है वो इस एरिया वेक्टर से थीटा इतना एंगल कर रही है. अगर ऐसा है, लेट द डायरेक्शन ऑफ मैग्नेटिक फील्ड मेक्स एन एंगल थीटा विद द एरिया वेक्टर, then magnetic flux is the dot product of magnetic induction and area vector. This is first important formula in this chapter. So phi is equal to, by definition of dot product is the product of magnitude of two vectors multiplied by cosine of angle between them. So BA cos theta. This is for one turn. If it is coil, then it is for one turn. If there are n number of turns, then we will add here n in the multiplication. So magnetic flux is equal to BA cos theta. सेकंड इंपॉर्टेंट फार्मूला इज मैक्सिमम फ्लक्स कब होगा, तो जब एरिया वेक्टर ए बार हम कंसीडर करते हैं और मैग्नेटिक इंडक्शन हम एरिया को परपेंडिकुलर लेते हैं, तो इनमें का एंगल जीरो हो जाएगा. मैग्नेटिक इंडक्शन इज परपेंडिकुलर टू द एरिया, सो हियर थीटा इज जीरो, एंड इन दिस केस मैग्नेटिक फ्लक्स पासिंग थ्रू द एरिया इज मैक्सिमम, एंड दैट इज BA cos जीरो, दैट इज BA. Then unit of magnetic flux, very important, this is Weber or Tesla meter square. This is very important unit for magnetic flux. Then we have observed Faraday's law of electromagnetic induction. According to Faraday's laws of electromagnetic induction, according to first law, whenever there is a change in magnetic flux associated with the coil, an EMF is induced in the coil. That is, Faraday's first law gives the cause of induced EMF. इस वजह से होता है change in magnetic flux. Second law gives magnitude of induced EMF. So according to Faraday's first law, whenever there is a change in magnetic flux associated with the coil, an EMF is induced in the coil, and the induced EMF is directly proportional to rate of change of magnetic flux. जितना magnetic flux ज्यादा बढ़ेगा या बदलेगा, उतना ही ज्यादा EMF induce होगा. So we can write E is equal to d phi by dt. Then we have discussed Lentz's law. लेंज ने सिर्फ फैराडे के लॉ में क्या किया, निगेटिव साइन डाल दिया. E is equal to minus d phi by dt. According to Lentz's, the induced EMF always opposes its cause. That is, induced EMF always opposes rate of change of magnetic flux. Then the next important formula is self-inductance. We have phi is equal to Li. This self-inductance L. Also, E equals to L di by dt. This is very important formula. Or we can also write L is equal to E upon di by dt. This is formula for self-inductance of an inductor coil. Its unit is volt second per ampere. SI unit of self-inductance, and same for the mutual inductance. Then we have observed formulae for transformer. For transformer, we have observed EMF induced in secondary coil upon EMF induced in primary coil is equal to number of turns of secondary coil upon number of turns of primary coil is equal to current flowing through the primary coil upon current flowing through the secondary coil. This is important formula for transformer, and this is called as a transformer ratio. We generally represent it by small k. This is called as a transformer or turns ratio. Again, in case of ideal transformer, output power must be equal to input power, that is ESIS is equal to EP IP. Output power is equal to input power. Again, efficiency of a transformer is output power upon input power, that is EP IP upon ESIS upon EP IP, that is output power upon input power. Efficiency of an ideal transformer is always 1, and for all other practical transformer, efficiency is less than 1. This is first part of electromagnetic induction. So this is formula for electromagnetic induction. Now let's go for the second part of electromagnetic induction, that is alternating current. We will see the formula for AC now. For alternating current, the most important formula is EMF E is equal to 2 pi f NAB cos theta or cos of omega t. This is most important formula, 2 pi f NAB cos omega t, where whenever cos omega t is maximum, E will become maximum and its maximum value is given by 2 pi f NAB. This is general formula for EMF induced in a coil rotating in a magnetic field. So E0 is equal to 2 pi f NAB, or we can also write here sin omega t. Sin omega t भी हम ले सकते हैं. So E is equal to, if we substitute E0 is equal to 2 pi f NAB in this equation, E equals to E0 sin omega t. This is general formula for EMF induced in a coil rotating in a uniform magnetic field. Now 2 pi f NAB, this is called as the peak value of EMF, and whenever we consider induced EMF, it is a function of sign, and as it is a function of sign, its variation with time will show us a sinusoidal curve. From this equation again, E0 is equal to 2 pi f NAB, that is induced EMF depend on the frequency of AC. In India, the frequency of AC is 50 Hertz. This is very, very important. Now next important formula in AC is AC with resistor. Whenever we consider AC with resistance, the figure is a resistor connected in series with AC. Let this AC supplies EMF E0 is equal to E0 sin omega t. Then by definition or by derivations, I is equal to I0 sin omega t. For resistive circuit, this is called as a resistive circuit in AC. And for resistive circuit, current which is along x-axis, EMF is again along x-axis. So current and EMF are in same phase. Sin omega t, as omega t are equal, we can say that EMF and current in the AC are always same. But for which? For resistive circuit. So EMF E and current I are in the same phase for resistive circuit, that is AC with resistance. Then next is AC with pure inductor. When we consider AC with pure inductor, let I equals to I0 sin omega t is the current supplied by the AC. Then we have E equals to E0 sin of omega t plus pi by 2, that is, whenever we consider along x-axis current I, the phase of EMF leads the current by pi by 2. So the phasor diagram for this will be, for inductive circuit is E is along positive y-axis and I along positive x-axis. That is, EMF leads the current by 90 phase and current lags the EMF by 90 phase. So EMF is ahead of current in inductive circuit. Next, again, if we consider inductive circuit, then E0, that is peak value of EMF, is equal to peak value of current into XL. This XL is called as opposition offered by inductive circuit to the flow of current, and this XL, this opposition offered by inductive circuit to the flow of current, is represented by omega L, and it is called as inductive reactance. This opposition offered by inductor coil to the circuit, to the flow of current in the circuit, is called as inductive reactance. Resistance and reactance have same function, opposition to the flow of current, but resistance, whenever opposes current, it consumes power, electrical power, it consumes watt, and pure inductor does not consume watt. That's why pure inductor is the circuit in which inductor is present is called as wattless circuit, or the current which is flowing through the inductor coil is called as idle current, because it does not consume any power. Now, whenever we consider capacitance in the circuit, capacitance with AC. At that time, if R is equal to I0 sin of omega t, then EMF E is equal to E0 sin of omega t minus pi by 2. That is, in capacitive circuit, as we previously observed that in inductive circuit EMF leads the current by pi by 2, but in capacitive circuit EMF lags behind the current by pi by 2. That's why we have the phasor diagram for capacitive circuit as EMF lags behind, here EMF leads the current. In the capacitive circuit, peak value of EMF is given by I0 into XC, where XC is 1 upon omega C, is called as a capacitive reactance. XC is equal to 1 upon omega C is called as capacitive reactance. Omega is 2 pi F. Here, if we consider inductive reactance, then XL is equal to 2 pi FL. That is, XL is directly proportional to resonant, directly proportional to the frequency of AC, and capacitive circuit is inversely proportional to frequency of AC. Whenever this frequency becomes 0, then XC becomes infinite. Whenever F is 0, XC becomes infinite. Infinite means जब AC की फ्रीक्वेंसी 0 हो जाएगी तो कैपेसिटर सर्किट जो है उसमें से जाने वाले करंट को इनफाइनाइट अपोजिशन करेगा. इसका मतलब AC की फ्रीक्वेंसी 0 हो गई तो कैपेसिटर करंट को फ्लो नहीं होने देगा, और AC की फ्रीक्वेंसी 0 होना इसका मतलब AC चला जाना और DC आ जाना. इसका मतलब जब हम AC को जाने देंगे और DC को आने देंगे तो कैपेसिटर उसमें से करंट को फ्लो नहीं होने देगा. इसलिए हम कहते हैं कि कैपेसिटर का काम है DC को ब्लॉक करना. आइए अगले फॉर्मूले भी देखते हैं. अब LCR सर्किट के फॉर्मूले देखते हैं. अब अगर LCR हो सीरीज में, L, C और R जब सीरीज में हो तो यहाँ पे एक इंपॉर्टेंट बात हमें जो ध्यान में रखनी है वो ये है कि इंडक्टिव कॉइल और कैपेसिटर ये जो है सर्किट में रिएक्टेंस देते हैं. इंडक्टर की वजह से एक्सेल रिएक्टेंस आता है, कैपेसिटर की वजह से एक्सी रिएक्टेंस आता है, और ये दोनों का जो फेज है 180 डिग्री अपोजिट होता है. इसलिए इनका रिजल्टेंट हम लेते हैं एक्सेल माइनस एक्सी. तो इस LCR सर्किट में रिजल्टेंट रिएक्टेंस एक्सेल माइनस एक्सी होता है, और ये जो रेजिस्टेंस है ये भी करंट अपोजिशन का काम करता है. इसलिए टोटल अपोजिशन यहाँ पे दो तरह के है, एक तो ओहमिक अपोजिशन और एक जो है वो नॉन ओहमिक अपोजिशन. और ओहमिक और नॉन ओहमिक अपोजिशन जब सर्किट में प्रेजेंट हो तो उस सर्किट के टोटल अपोजिशन को हम कहते हैं इंपेडेंस. और इंपेडेंस का फॉर्मूला है LCR सर्किट में R स्क्वायर प्लस XL माइनस XC ब्रैकेट स्क्वायर. This is a non-ohmic opposition. This is ohmic opposition. This is wattless. This is with watt. So R square plus XL minus XC bracket square. इसकी फेजर डायग्राम हम इस तरह से निकालते हैं. हम इसको फेज पाई लेते हैं, इसको हम R लेते हैं, इसको Z लेते हैं और इसको XL minus XC हम बताते हैं. So this is called as a phasor diagram and this is impedance. अब जब सर्किट में सिर्फ इंडक्टर ही होगा और कैपेसिटर नहीं होगा, तो अगर सर्किट में कैपेसिटर नहीं हुआ तो इसका मतलब सिर्फ रेजिस्टेंस होगा और इंडक्टर होगा. अगर LR सर्किट है तो यहाँ पे जो इंपेडेंस होगा इस तरह से होगा R स्क्वायर प्लस XL स्क्वायर, क्योंकि XC 0 हो जाएगा. अगर इसी सर्किट में इंडक्टर की बजाय कैपेसिटर हो तो हम इस तरह से R स्क्वायर प्लस XC स्क्वायर लिख सकते हैं. तो ये एक बहुत इंपॉर्टेंट पार्ट है. अब उसके बाद सबसे इंपॉर्टेंट फॉर्मूला है रेजोनेंस का. रेजोनेंस में क्या होता है, इंडक्टिव रिएक्टेंस और कैपेसिटिव रिएक्टेंस इक्वल हो जाते हैं, और यहाँ पे जो फ्रीक्वेंसी हमें मिलती है उसे हम रेजोनेंट फ्रीक्वेंसी कहते हैं. उसका फॉर्मूला है 2 पाई अंडर 1 अपॉन 2 पाई अंडर रूट ऑफ LC. और अगर सर्किट में रेजोनेंस हुआ तो XL माइनस XC 0 हो जाएगा और सर्किट का इंपेडेंस जो हो जाएगा वो पूरी तरह से रेजिस्टेंस हो जाएगा. इसका मतलब सर्किट में जब रेजोनेंस होगा तो इंडक्टेंस एंड कैपेसिटेंस एक दूसरे को कैंसिल कर देंगे और उस सर्किट में L और C दिखने के बाद भी उसका फंक्शन कुछ नहीं रहेगा. तो सर्किट पूरी तरह से क्या हो जाएगी, रेजिस्टेंस हो जाएगी. तो एट रेजोनेंस इन LCR सर्किट 100% वर्क्स एज ए रेजिस्टिव